Welcome to Across the Globe. Today we will learn about decorators. Decorators in Python are used to alter the functionality of functions or methods without actually changing their code. They are designated with the symbol preceding the decorator function's name. For instance, a logging decorator can be applied to a function to track its execution time or input parameters without altering the original function's logic. This aids in keeping the code modular and clean by separating concerns and enabling easy addition or removal of functionalities from functions or methods. To create a decorator in Python, you need to define a function that takes another function as an argument and returns a new function. This new function enhances or modifies the behavior of the original function. Decorators are commonly used to add additional functionality, like logging or timing, to existing functions. In the provided example, the myDecorator function is defined to wrap around another function. The func parameter refers to the original function that the decorator will enhance. Inside myDecorator, a new function named wrapper is defined. This wrapper function executes additional actions before and after calling the original function func. To apply the decorator to a function, you use the decorator name syntax above the function definition. In this case, myDecorator is placed above the sayHello function. When sayHello is called, it executes the wrapper function, which includes the desired behavior modifications before and after executing the original sayHello function. By understanding and implementing decorators, you can efficiently enhance the functionality of your code without modifying the original functions. Decorators are functions in Python that modify the behavior of other functions. When a function is decorated, it is wrapped inside the decorator function, enabling additional functionality to be executed before or after the original function. In the provided example, the authenticate decorator is used to ensure that only authenticated users can access the protected function. The authenticate decorator checks if the user is authenticated before allowing access to the protected function. If the user is authenticated, the protected function is executed. Otherwise, a message stating "not authenticated" is returned. This allows developers to easily add authentication checks to multiple functions by simply decorating them with the authenticate decorator. It helps in keeping the authentication logic centralized and promotes code reusability. Real-world applications of decorators include adding logging to functions to track their execution, applying rate limiting to limit the number of times a function can be called, or caching the results of functions to improve performance. Python leverages built-in decorators such as @property, @classMethod, and static method to enhance code clarity and organization. When used, these decorators convey the intended behavior of the annotated functions, making the code easier to understand and maintain. For instance, in a scenario where a class requires methods that are related to the class itself rather than an instance, the @classMethod decorator is employed. This signals that the method operates at the class level as opposed to the instance level. Similarly, the @staticMethod decorator is utilized when a function within a class does not require access to either the class or instance. This signifies that the method is static and does not depend on instance or class-specific data. Lastly, the @property decorator allows defining a method that can be accessed as an attribute, adding a layer of abstraction for handling attribute access. This is especially useful for scenarios where computed attributes are needed. By applying these decorators judiciously, developers can enhance the structure and organization of their Python code, fostering readability and maintainability. Think of decorators like adding toppings to a pizza. Just like how adding different toppings can enhance the flavor of a pizza, decorators can enhance the functionality of a function in a program. You can choose to add different toppings, decorators, to different pizzas functions based on your preferences. The toppings decorators can be added on top of each other to create a unique combination of flavors, functionality. Hey, Code Conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code snippet above demonstrates the use of decorators in Python to enhance functions with additional functionality without modifying their original code. In this scenario, two decorator functions, add cheese and add pepperoni, are defined to add cheese and pepperoni toppings, respectively, to pizzas. These decorators wrap around the target functions, plain pizza, cheese pizza, and pepperoni pizza, to extend their behavior. Add cheese decorator enhances a function by adding cheese topping. Add pepperoni decorator enhances a function by adding pepperoni topping. The wrapper function inside each decorator carries out the additional action, e.g., printing the topping being added, and then calls the original function func to maintain the core functionality. The target functions are then decorated using the @decorator syntax, with cheese pizza decorated with add cheese and pepperoni pizza decorated with both add cheese and add pepperoni. When the functions are invoked, 1. Plain pizza prints plain pizza is ready without any toppings. 2. Cheese pizza adds cheese topping before printing cheese pizza is ready. 3. Pepperoni pizza adds cheese topping then pepperoni topping before printing pepperoni pizza is ready. This example showcases how decorators can be used to modularly extend the behavior of functions, allowing for easy customization and reuse of functionality. One real-world example of decorators in the industrial context is in web development frameworks. For instance, in Django, a popular Python web framework, decorators are used to add functionalities to views, such as authentication, caching, and permission checks. Another application of decorators can be found in microservices architecture. Decorators can be utilized to apply common functionalities like logging, error handling, and authentication across multiple microservices without duplicating code, ensuring consistency and maintainability. In conclusion, decorators play a crucial role in adding reusable functionalities to functions or methods, making code more modular, concise, and maintainable in various industrial scenarios across the globe. Keep learning, stay curious, and I'll catch you in the next video.